Okay, cool. So you guys can see my screen and everything?
Mm-hmm.
Perfect.
Yeah, sure.
So obviously we're a San Diego machine learning group. We're here to read the Deep Learning with PyTorch book. There's the link. Right now it's free on the PyTorch website, so you can buy the physical copy if you want the physical copy, but there's also a free PDF you can get off their website. You just plug in your personal information and then they'll give you the download link. So if you want to follow along for free, that's an option. Just an overview of our goals for today. We'll discuss the format a little bit. I'll give some tips on reading the book and getting as much value as possible out of the group. And then we will also discuss chapters 1 and 2. If you haven't read it, don't feel too bad. It's not that meaty of a set of chapters, so you won't be too far behind. As far as the format goes, typically it's pretty loose. We're going to try to run it a bit tighter and follow the book more closely this time because it's a pretty interesting book we're reading and it's really valuable skills. So we'll try to stay on task. In the past, we've kind of let things meander and people have their own conversations about things. So we'll try running this one a little bit stricter and follow the book just so we can make sure everyone gets the most value out of this as possible. We'll just discuss what we read this week. I'll kind of just run us through an outline I made just to at least get us started. And then in later weeks, we might open it up to have more interactivity and more questions and stuff like that. The gist is chime in whenever you have a question, either in chat or in voice if you're comfortable. I know personally for me, I don't like interrupting people while they're speaking, so I typically would not chime in voice. So if you are more comfortable going in chat, just type a question in chat and I'll try and address it. And the way we typically do it is we will read our chapters. So for this week, it's chapters 1 and 2. And then at the end, we'll look ahead a little bit and we'll say, okay, should we read chapters 3 and 4 or just 3, or what are you guys comfortable with? So I know chapter 30 is about 30 pages, and I think Ted, you said that between the two, it would be about 60 or something like that. So doing 2 chapters might be a bit ambitious, but we can just discuss that at the end, depending on what you guys are comfortable with. And you can always participate if you haven't read. We'll generally cover the topics well enough that even if you didn't read, you'll still learn something, either just some Python trick or some new concept or whatever. You don't have to feel pressured to read every single week. If you miss a week, you don't have to fall behind or completely ditch the group just because you weren't able to, you were busy with work or whatever was going on. In terms of tips, just try to get through the book. You don't have to, there's not going to be a test. You don't need to memorize everything. For me, I think that I get the most value out of going through these books with just the goal of exposure to the concepts. It's not necessarily mastery that I'm going for. We might go across GANs and variational autoencoders, and you might go through and you say, I don't really know the nuts and bolts behind these, but then when you actually go to solve a problem at work or somewhere else, you can at least say, oh, I know that this concept is relevant. I can go Google a tutorial about it and I can follow along with that. So you don't have to absorb everything. And if there's something you're finding difficult, you can just come to the group and ask questions and we can discuss and figure it out or help you along. Another tip is there's going to be a lot of examples in the book. If you really want to master it, I highly recommend taking it and transferring it to something that you specifically care about. So whether that's your specific area of research or your domain or something you're doing at work, if you can say, oh, I learned about an LSTM, this might apply to my work, you'll remember it better and you'll get a better mastery if you actually apply it to something new. If you just follow along with the examples, you'll probably get the gist of it, but you won't have the kind of intuition and the deep knowledge that you get from actually working on projects with this stuff. recommend taking notes, bringing questions. If there's anything that doesn't make sense, just bring it here. And I highly recommend that people be social. That's part of the group. So part of it is learning, but part of it is also meeting people and networking, and making friends. Almost all of the jobs that I've gotten in machine learning have been from people that I knew from meetups, from working on competitions, from other random things. So a lot of the value comes from actually sticking your neck out and introducing yourself to people and finding people with similar interests and stuff like that. So I highly recommend, on the next slide, we'll give a layout so people can introduce themselves on the Slack channel if you guys are in there. So I'm figuring most of you are already in the Slack channel, but if not, I can copy this in the chat and you guys can join. We've got a MO Bookclub channel, and I highly recommend that anyone who wants to can just put in a little blurb about themselves. Typically when we do this meetup in person, it's easy for us to have sort of spurious conversations where it's just two people sitting next to each other and they start talking, and it's a little bit harder when we're in a big Zoom call with 30 people and only one gets to talk at a time. So I highly recommend going over there. Tell people what you're interested in, tell people what your experience level is, share machine learning memes. I really don't care. Just do something to announce your presence and meet other people. And I think we'll have a good time if everyone does that. So that's it for the intro slides. Now I think, Ted, you had a quick poll for us to conduct just to see where everyone is in terms of different levels of knowledge.
All right, so I launched the poll. It's just 3 questions, and we'll show the results, but just to kind of see where people are at in terms of, you know, we want this to be a welcoming group, whether you're a beginner or you're experienced, and so then you can kind of see where other people are. You can see, you know, if you're a beginner, there are other beginners here. There are other people who haven't used PyTorch, and so you can see who else is here. But also just some feedback in terms of, we want to make sure if it's appropriate to do some level setting and you know, try to be at an appropriate level so that people are all following the conversation. So I think most people have found the polls. I'm still working out how all this Zoom stuff works. So clearly there are people who have figured out. I don't know if you have to actually like click. Somebody shared. Do you have to actually click on a menu? Did it pop up on your screen?
I had to click on participants.
Mine just popped up.
Right.
Mine
for me,
just
it
popped up.
Yes,
Yeah,
mine just
mine
get up.
Just popped up. It just popped up
for me.
Okay. All right, we'll give it another sec. If it didn't pop up for you and you're interested in doing the poll, please go ahead and feel free to answer the poll. All right. All right, cool. So I'm gonna end the poll and show everybody the results so you can all see it. So experience, you can see there's a mix, right? Most people said they were either beginner or intermediate. A wide smattering in terms of people experience with deep neural networks. And almost half the people that answered haven't played with PyTorch yet. So, so again, there's a lot of company for people if you're new to this, and so I'm excited. I think this is going to be a good book for this group. Anything else, Ryan?
No, I think that's it. That's interesting to see those stats. I haven't formally asked people that before.
Yeah, I mean, sometimes we ask people to share, but it's a little bit, you know, hard if you're just like physically in a room and someone's putting you on the spot. Are you a beginner? Yeah. All right. So I think, Ryan, we're gonna start to talk about the book, but do you want to just encourage people in the background if they want to just like say hi or post something in the Slack. You know, in the past we found like different people are both like in bio or, you know, in similar fields. And so then that's something where, you know, if you're interested, by all means, you know, talk to each other. Let's see here. I posted the Slack link, but it looks like it got broken across 2 lines. So, so I think you're going to have to like manually copy the link, including the part that's not highlighted, and paste it as one whole thing if you want to join the Slack to say hi.
Somehow I got a picture with butterflies instead of forum. I don't know why.
Let me.
The underscore somehow is breaking.
Yeah.
When we post it in the chat.
I made, so this will serve 2 purposes. This is actually convenient. So I made a LinkedIn post. Hopefully that works. Yeah. So this LinkedIn post is going to serve 2 purposes now, because it has the links to my notes for the chapter, and it also has the link to the meetup and all of that stuff. So you can go through the meetup and then grab the Slack link as well. And then if you want to, you can join into the ML Book Club channel and then post a little bio and meet the other people who are in the group right now. So feel free to do that, and we'll jump into the book now, I guess. I just heard a whole bunch of clicks of people joining. So chapters 1 and 2, this was really just an overview, learning what is PyTorch, what do we use it for. In the first section, they talked about 2 interesting applications of AI just to get people excited about what's going on with this stuff. And it was kind of interesting. They linked to this Talk to Transformer website. I don't know if you guys have played with this before. It's pretty interesting. You can just plug in some text and then it will try to do like a very advanced autocomplete, where you just say like, the San Diego Machine Learning Group is about, and then it will just fill out the rest of it and write a whole essay for you basically about the San Diego Machine Learning Group. And it's just this text model that was taught to basically fill in the blanks and continue some text. And they have it in the book, but it's interesting because the website is actually down right now because the server costs are so high. So unfortunately, no one can play with that right now, but my stand-in tool to show off the same tech, but in a kind of different domain, is this game called AI Dungeon. I don't know if you guys have seen this before, but basically it's a game where it uses the same concept. So it's trying to generate a story for you, but they've done it in a sort of setting that's sort of like Dungeons and Dragons or something like that, where it's just a text adventure. And you can just plug in different options and it will give you a starting point. And then you kind of just build this whole story, plug in some text, and you just write a sentence. You say, I open the door, I do whatever. And then it will try to just generate text that generates a story for you, and you can kind of play with the text generation and work through that. So if you guys want to play with that, that's an interesting application of the same text, the same model that's in Talk to Transformer. So that's just a fun little thing to play with to get you excited about what you can possibly do with PyTorch. So section 1.1, they're talking about the deep learning revolution. The previous book we read, that was all about feature engineering and sort of more old school machine learning. And a lot of that has sort of gone away with the new deep learning tech that everyone's been playing with. And so in the old school, if you wanted to build a classifier that was able to detect different kinds of dogs or cars or any number of different things, you would have to hand engineer a whole bunch of features. So you say a dog is sort of this color and it's got fur, and you have to figure out in terms of like raw pixel values of a picture, how do I translate that into something useful? But deep learning is able to automatically generate those features and create something useful out of it. And so that's kind of the big advantage and why everyone's hyped up about it. And it's proven to be way more accurate in a lot of cases, even when you have someone who's an expert in dogs or something like that, you can still make something more accurate using deep learning than their domain knowledge because of how powerful deep learning is. And then in section 1.2, they talk about PyTorch for deep learning, just explaining what it is. It's a library that helps us build deep learning models and projects. It helps you deploy. You're able to train a model, you load data, it does all of that for you. You just have to write a little bit of code and build out the architecture around that. And they mentioned that the book is going to walk us through hands-on examples for various different projects. In one of the later projects, they mentioned that we've got a 120 gig medical image data set, so we can see what you can do when you have data and what all of that pieces together to make. I'll stop every couple sections just in case anyone wants to chime in or has any questions. Do you guys have any questions, comments up to this point on the book?
I was just curious about the Dungeons and Dragons game, whether it remembers where you've been.
I was just commenting on that. It does not.
Ah.
I played it for a long time, hoping I was like, "Oh, this is really cool," and it wouldn't remember what I was doing previously, though, or something I had done. I mean, it's cool to see, but it's not a full DM yet.
So, yeah, got it. So, you have an unlimited quiver of arrows.
Mm, yeah. It does have some aspect of memory, but it's only a certain degree of text, I believe. So it might look a certain number of tokens back. That includes its backstory, but I think if you go too far, and I don't think it directly is like remembering anything, it's just generating text based off of what it's seen.
Yeah. Look forward to somebody actually populating a database, a knowledge base with the things you've done and revisiting them.
Brian, I wanted to bring up the topic of old school machine learning, which is what I've always done in the type of application, that's not image recognition or speech recognition or NLP, natural language processing.
Mm-hmm.
People that I know that have tried both say that for your, say, classic, like generate a FICO score out of your typical tabular data, that the traditional methods still work. I mean, people go to gradient boosting machines and not to deep learning. I was hoping that deep learning would do something. I myself didn't do it. I asked some other people back when I had a company, and they tried to use deep learning to generate some features. And it would underperform the gradient boosting machine by a little bit. Now, we weren't experts, and maybe that will change. But at the moment, it seems as if, there are these two domains.
Yep.
And so deep learning has its own domain, and then there's a lot of other problems where you want to be more, dinosaur-like.
Yeah, the domain really boundary, I think, is at the dimensionality of that table. So if that table has 1 million columns, then I think gradient boosting will fall behind deep learning, especially if there's a predictable relationship between consecutive columns.
I think, if I may,
I just wanted to ask about bioinformatics then about that, because, if you're looking at SNPs data, for example, there's going to be some relationships, at least when the, when it was coiled. And I don't know if that's been exploited yet by deep learning.
The challenge with that is there's a lot of domain knowledge in that space where they're able to reduce the dimensionality from the billions of dimensions that actually exist down to, so it's not actually a natural language string that they process. they just look at the diff between a normal human genome and whatever's in you, the reference, and the SNPs are a massive reduction in dimensionality that happens, and that's where deep learning would only help if you did not have that capability.
I asked my daughter about it. She's genetics. She works with machine learning for genetics. And exactly this question, do they consider the shape of chromosome, that it is a spiral? And she said that they don't at this point. But she told me I can drop you my data and you are free to explore it.
Yeah, what she's talking about is 3D genome sequencing. So that's an expensive process where you can actually see how your genome folds together, and they're trying to build deep learning models that can simulate it, so they don't have to actually sequence it.
My question is then how would we handle, or will we be able to handle in the future, that the kind of multiple modalities of the data, right? Like in terms of processing both tabular data and, let's say, visual data at the same time as two streams of input.
That's a great concept. What you can do is you can typically take one of the embedding layers within a deep learning model that's either been pre-trained in an unsupervised way or been specifically trained on your data, and you can use that as your feature. So you can use it as a feature reduction or feature extraction tool, rather than using it as an actual predictive tool on your entire data set for each individual column. So I do it regularly on tabular data for natural language strings, because almost all tabular data has a lot of natural language in it, and it works really well.
Gotcha. But I do very much appreciate Dan's point, because that's my dilemma as well. Like a lot of what we have been taught or have been practicing in, at least in the market research field, doesn't really do much of the deep learning, but I can see the promise of the deep learning, and I'm still trying to see what could be the applications that are particularly relevant here.
Hobbs, you mentioned in this hybrid modeling, which I've been interested in, and I've tried it myself, but very primitive compared to what we're talking about now. And so you were using the DeepNet in order to extract features, and then those features would have been added to the conventional features, and maybe you put it into a GBM. Where in the network, I suppose you have many choices in which you can extract features. Do you have a typical location? Would it be like right at the end?
Ted and Ryan know about this.
Pardon?
Ted, yeah, you're right. It's the last layer before you make your prediction.
Oh, okay.
Typically,
right.
but you could, depending on your problem, you may find, if you look deeply into your network, you can sometimes find other layers that have less constriction of the information, less dimension reduction, and they can sometimes be more valuable. Which it's usually called the neck down point, or the bottleneck in your network. So there's a UNet that Ryan introduced me to a few months ago that has that bottleneck at a different location than is typical, because it's a generative network. So you have to look at basically you're looking for the narrowest layer, the smallest layer with the lowest dimensionality in your network.
Okay, cool.
So going back to Dan's original question, we've gone 3 or 4 layers deep on that one now. I would just say that deep learning, in my experience, is very useful in the specific domains where we've figured out some successful kind of domain injection. So when we do vision, we do convolutional neural networks, and when we do text, we do transformers or LSTMs. When we do something that explicitly encodes some understanding of the nature of the data we're looking at, deep learning seems to win. But like you were saying, gradient boosting and stuff like that wins on tabular data typically, when we can't do anything that specifically exploits that with deep learning. But there are lots of reasons to still choose deep learning even over GBMs. depending on what's going on. I've been studying a bunch of reinforcement learning recently, and even on tabular things, you still typically get better results out of neural networks just because you can directly use the gradients in order to optimize the neural network, and doing that sort of iterative update is much easier on neural networks than it is on decision trees and stuff like that. So there's pros and cons. I won't say that deep learning always wins, but there are many advantages, and it's definitely a useful skill to have in people's toolbox.
Hey, Ryan.
Yeah.
Going back to the outline, in terms of why PyTorch, I'm excited to read the book, excited to play around and learn more with PyTorch. But one of the things that I think is useful to know is, I don't think if you do something in PyTorch, you're ever going to win an award for sort of the fewest lines of code, or sort of the highest level of abstraction where it's just like, oh, I just did this and that. You're kind of, it's still at a fairly intermediate to low level, somewhat raw-ish representation of the numerical data. And so, I don't know exactly where I'm going with it, but I think it's just fair warning, like, if you're doing something with Keras as a high level, package on top of TensorFlow, you may be able to do something in whatever, 20 lines of code. But it looks like in PyTorch, it's probably going to be, 30, 40 lines of code, and the lines of code each might be slightly longer, more,
Mm-hmm. Yeah. So that's, if any of you are familiar with Keras is this layer that's built on top of TensorFlow that kind of simplifies a lot of the stuff that you're doing. But the trade-off you make is that you don't necessarily have access to as much stuff. So you don't have all of the flexibility. And PyTorch kind of sits somewhere in between TensorFlow and Keras in terms of complexity. And so I've been switching over to PyTorch over time. So I originally learned with TensorFlow, and then I learned Keras because it was really nice because it simplified a lot of things. And then I've been switching back to PyTorch as I've been going deeper into things and picking up just all of the flexibility and the nice new features that are coming out with it. And a ton of research is being done with PyTorch as well. So if you have some state-of-the-art model that just pops up and you write a research paper about it, it's probably coded in PyTorch now. And so there was a certain point where I was like, I have to learn PyTorch because all of these new things are being implemented in it, and I need to be able to understand a bit about it. And I've come to like it a lot. So I think that's a good point from Ted, is it's not necessarily going to be less lines of code, but it gives you a lot of freedom, and you're able to explicitly code all of the stuff that you want. And if you want to customize something, then it's relatively easy to go in and actually alter things when you're doing experiments.
I wanted to mention a set of videos that I watched recently from MIT. They're a set of lectures that were, I guess, intended to be, inter-semester or something. And they were in January of this year. And there's, I think, a total of 9 to 12 lectures. 6 of them are pretty substantive, but they're also an intro to deep learning. And I found that very, very useful. So when I read, the material in the book here, I already had familiarity with those concepts from those lectures. And the nice thing is that you just sit and watch. It's less effort than reading. They use Keras, and I thought when I first saw a Keras program, I thought, holy smoke, this is easy. One line of code per layer, and you know what you're doing, and it's boom, 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 and it's done. And then I thought, oh, I'm not going to like PyTorch, but after seeing that, but I can see the charm of PyTorch as well. And at least, if someone's finding some of this stuff relatively overwhelming or more information than you're ready for, I think those lectures would bring you up to speed, pretty quickly. They're definitely intro, There's nothing very advanced about them, and each one is about an hour. And I think they are really, really good. The quality was, you would expect MIT to be good, but when I saw it, then I thought, oh, wait a second, this is a different level than a lot of the videos that I've been seeing on YouTube. This is really professional. I'm not talking about production level. I'm talking of the video itself, but the content was just superb. Reminded me of what it was like to be back in grad school, and I liked it.
Yeah, I think that Keras is actually pretty good to learn on because it simplifies a lot of things. There's always trade-offs, right? Because if you add abstraction, then you don't necessarily get to see all of the nuts and bolts of what's happening. So I think that it was good for me to have started with Keras and then transferred to PyTorch, because I said, okay, now I know at least some of the nuts and bolts, and then going to PyTorch allowed me to extend that even further. But it seems like most people are starting directly with PyTorch now. And I think that it's good to have the lower level understanding a lot of the time, and you can do things a lot more custom. But there are good resources in Keras. If you have the link to that, feel free to share it. I don't know if you already have. Bunch of questions in the chat. So is FastAI the parallel to Keras? I would say in some senses, it's not necessarily exactly the same thing, in that Keras is kind of just giving you a bunch of calls to TensorFlow and kind of wrapping a few different things. And now Keras is directly integrated with a new version of TensorFlow. And that's just the main way that you interact with a lot of TensorFlow now. And FastAI has some more kind of specialized tricks built around it. I haven't worked with FastAI a ton. I know that there were some people on Kaggle who were using that. And I tried to look at their code and work through what was going on. And I found it kind of difficult to go along with it, because a lot of this stuff was abstracted away. And I felt like, since I haven't taken the course that goes along with this additional framework, it was kind of difficult for me to say, like, okay, how do I even reload this model? How do I don't know what exactly is base PyTorch and what is FastAI custom functions and stuff like that. So I have sort of mixed opinion on FastAI, and it's a little bit different than Keras. It's not necessarily just a kind of wrapper. It has other things in there as well. Some of them good, some of them I just don't understand well enough to use. What are the main advantages of PyTorch over TensorFlow? I think that at this point they've pretty closely converged, so I couldn't point to anything in specific. I think a lot of people make comment about TensorFlow's API constantly changing. So they've had multiple different versions, and they've also had issues with there's 6 different ways to do the same thing, and it's not exactly clear which one is the recommended, which one's going to be the fastest. I specifically like the way that PyTorch does their data loading and data preparation. I always did stuff with Keras and TensorFlow, and then when I went over to PyTorch, it was like, oh, obviously this is much easier. It's doing multi-processing for me. It's loading things in batches, and there's just a lot of access to the sort of low-level stuff. And whenever I look at TensorFlow, I started on the old TensorFlow before even 1.0, so I have sort of a negative taste from when they didn't even have some of the nice things that they have now, where it was like, this is some graph that I can't see, and I have to build a whole thing, and then I have to do this separate run call, and then it gives me this error that doesn't make any sense. So I've used TensorFlow and Keras recently, but I haven't gone in as much depth as I used to, because I've been working with PyTorch more recently. Another question, what is Onyx? So Onyx is a standard format that a bunch of the different frameworks have agreed upon, and it's basically a way to encode the information about the neural network that is agnostic to all of the different frameworks. So if you have something in TensorFlow, you export it to Onyx, and it'll say, okay, this is the exact neural network architecture and all of the different stuff. and then you export it, and then you could theoretically load that in PyTorch or just call it with C++ or whatever else. And it's a standard format that works across all of them. And that's some standard that they just agreed upon. I haven't used it very much, so I can't really speak to it a whole ton, but that's my understanding of it. Now that TensorFlow 2.0 is available, does PyTorch still share the same advantages? I would say it's kind of a mix. I can't directly say that PyTorch is just completely going to win against TensorFlow. It kind of just depends on your use case. A lot of researchers have been switching to PyTorch. That's one of the main draws for me is if people are working in PyTorch, I also want to be working in PyTorch, and it just kind of simplifies things if I'm looking at their code and I already kind of know what they're doing.
So Ryan, if I could just share my 2 cents. So at the risk of trying to make some sort of prediction, you know, I don't go back as far with TensorFlow as you. And so, you know, TensorFlow 2.0, I feel like life is a lot better than it was under 1 or before that. And so I think that the gap is much smaller between TensorFlow 2 and PyTorch. And even now there are things like the other day, you know, I was building a, if you're familiar with image detection, ResNet, you know, inside Keras, you can really easily build ResNet modules, and it doesn't involve a lot of hairy code or anything like that. And there's a lot of things that now in TensorFlow you can customize pretty easily. And that used to be one of the big benefits of PyTorch. But if there's something that you want to do that isn't yet in Keras, then I don't recommend trying to make it work in TensorFlow. It'll be a lot more obvious in PyTorch. So if you wanted to do some kind of special memory management, if you wanted to do some work with splitting across multiple GPUs, if you wanted to do some custom activation function, like there are things that you can just sort of write some Python code and it'll work. And in TensorFlow, I don't know, you probably try to do stuff and then just get, like you were saying, Ryan, 80 million completely unintelligible error messages.
Yeah.
Anyone has any opinions as to, like Ryan, you mentioned quite a bit about doing research, you know, new R&D, cutting edge approaches in PyTorch, but for production systems and commercial systems, it seems like TensorFlow is more readily accepted and people have a little bit more confidence with maybe the support network for TensorFlow implementations. I was wondering if anyone has any opinions there or, you know, has heard from people in industry as to.
That's just because Google makes a large operating system on mobile phones. So if you want to deploy your model to mobile phones, they've made sure TensorFlow will work.
Right, yeah.
I think part of that is first mover's advantage. So TensorFlow has been around longer than PyTorch. So they've had more time to get that whole ecosystem built out. At H2O, we have models that are built in TensorFlow and Keras that are deployed. And we haven't really, there's a whole bunch of stuff built around it. So there's TensorFlow serving and a bunch of other kind of nice tools that are built around deploying models, but we're not actually using any of those. We're just using the model directly, and then we're deploying it how we normally deploy models. So I consistently hear the same thing that you've heard, which is TensorFlow is for production and stuff like that. But in my experience, I don't entirely understand the argument. I haven't used that side of things enough to directly say. One of the things they mentioned in the early section of this book was that they're going to cover how to use PyTorch in production and push all of that stuff out. So I'm interested to hear what they have to say on that front. I don't know enough to directly compare PyTorch and TensorFlow right now.
You're thinking web deployment, but when you go to mobile or IoT deployment, That's a different animal.
Yeah.
Yeah, and actually I realized I didn't complete my train of thought, but what I was going to say is that because, you know, university research is generally, you're trying to do something new, something different, you're trying to figure something out, so it's easier for them to do things, obviously in PyTorch under those kinds of rules. But if you keep getting all the new research and you keep getting the new state of the art coming out in PyTorch, and then you kind of have to wait for someone to refactor it as a TensorFlow model, I think it's just going to create an inexorable pull towards PyTorch. Now, whether or not ultimately there's like a unification of PyTorch and TensorFlow or whatever, you know, I don't know about that, but I think we're going to just continue to see a shift of things, and then ultimately, you know, to your question, it may take a little while before business really moves because they want to see all the other tools in the ecosystem around PyTorch. But I personally think PyTorch is a very useful skill right now for people, because I think it's just going to become more and more popular, and you're going to see the latest things always coming out first in PyTorch, you know, on Hugging Face or whatever. There's more stuff for PyTorch than there is for TensorFlow right now. And I think that's just going to continue to happen. So that's my two.
TensorFlow may eventually support Onyx. At that point, it's game over.
So section, we've pretty thoroughly discussed why PyTorch now. We can skip over that section. So 1.4, how PyTorch supports deep learning projects, helps us do quick math, basically, lots of operations. We can do stuff on CPU, we can do stuff on GPU with CUDA, working with tensors. It's got this awesome AutoGrad engine that does automatic differentiation and a whole bunch of other magic that makes neural networks and a bunch of other things work. This is kind of similar to TensorFlow, but it's just kind of that's one of the most core pieces of any deep learning library is automatic differentiation. All of the major stuff that we're interested in terms of neural networks is probably in the torch.nn section that's got the different convolutional layers and losses and optimizers and whatever else. All of that stuff goes in there. It's in that one section. They mentioned data loaders and data sets. That'll be important later on. Just basically, how do you load in the data? How do you pass it to your neural network? How do you form your batches? We can do multiple processors, multiple GPUs. We can even be networked across multiple systems. Potentially, you can do that in TensorFlow as well. But that's a very important feature, because if you have some massive model, you need to eventually scale it up potentially to more data and more GPUs and stuff like that. And they mentioned that you can export models with Onyx. And then section 1.5, looking at hardware and software requirements. They mentioned that you can do most with just a laptop. You don't have to worry about a GPU for all of them, but there's definitely going to be some projects where if you aren't using a GPU, you're just going to be waiting for days, basically. They recommend a GTX 1070 or newer, 8+ gigabytes of VRAM. Anyone with a gaming computer probably has that already. But if you don't, these are, I don't know the exact price on this now, probably somewhere in the range of $200, $300 now. But I would say it's definitely a worthy investment to put money in something nice, because that'll be the difference between you doing experiments that take 8 hours and you just sit idle the whole day, and 1 hour and you're able to do multiple experiments in a day. If this is something you're really interested in, I highly recommend putting the money up front. It'll make a big difference in your experience in toying with this stuff.
Ryan,
yeah.
I'm interested in putting a good NVIDIA card in my Dell T440.
Mm.
And Dell doesn't want you to do it. And they tell you, no, you got to buy a new $5,000 machine. But, you know, I mean, one of these good cards, like you said, a 1070 is a couple $100. I think there's like the 2060 now. There's one really good high-end one, costs about $2,000, and it's really super powerful.
Mm-hmm.
And I can't find anything on the internet that says, how do you do it? Dell just says, don't do it. And they'll just stonewall you.
Yeah, yeah. I think, I don't remember if it was 2 weeks ago or beyond, but I remember I showed you a Dell video showing how to pull the thing out. So Dell does have some guide videos that I can show you that show you how to remove a GPU, add a new GPU, and stuff like that. The big question with your system is probably going to be, I think last time we determined that you do have the PCIe slots to put the GPU in, and then the question is going to be if your power supply has the proper wattage and the proper connections to actually power that. And if that's the case, then I would just ignore Dell's recommendation, just put the GPU in, and it'll work for sure. I've installed in lots of systems.
Thanks.
Yeah. And so if anyone doesn't have access to that stuff, if you don't have the money to buy a GPU, or if you just want to get your feet wet before you commit to anything, you can use Google Colab, which I would compare to like Google Docs, but for running Jupyter notebooks. And this comes with Python installed. It can potentially come with PyTorch and any other things you need. And then it also has access to GPUs and even TPUs if you pay for the right tier. There's free tiers that will give you some access to some things, and then higher tiers that will give you access to even beyond that. And so that's a environment I highly recommend. Another one is stuff on Kaggle. So if you go on Kaggle, they'll also give you access to GPUs and TPUs, and you can just play within that environment. And it's got all kinds of data science packages pre-installed. So that's something I also recommend. 2 options in case you don't have a system of your own that you can compute on. Questions in the chat. Torch script and eager mode. I'm not particularly familiar with those. I can't really speak to those yet. I'd have to do more research. I know that eager mode is when TensorFlow went from that kind of annoying build a graph and then hit run and all of that stuff to just directly doing the math when you request it. I'm not as familiar on the Torch script side. I don't know the exact definition of that. I might be using it all the time and I don't know. I'm not. I've seen the name Torch script, but I haven't directly looked at what that section of PyTorch is doing. People use EC2 for GPUs. I know a lot of people do. A lot of people with their jobs have access to EC2 systems. At my work, we have access to various different AWS instances, and we also have a service that's kind of built on top of that that allows us to just deploy our software on top of EC2 along with GPUs. My recommendation is not to use that for your personal use though, because the cost goes up very, very quickly in reference to what you could get for just your own system. It's one thing because it's very scalable. So if you have 60 different employees and you only need to use it sometimes and stuff like that, then EC2 definitely makes sense. But if it's just you and you're going to be running consistent experiments and stuff like that, you can invest in a $500 graphics card and you'll if you were doing the same thing on EC2, you would run through that budget within a week because those systems are fairly expensive just per hour. So my recommendation, if you're doing it for personal use, is to get your own system, unless you have some really extreme requirement. Experience with Sagemaker. I have heard good things about Sagemaker. I haven't directly used it. My manager from my previous company says that their company is using it now in some of their work. I know that it's got various different things in terms of data labeling and automatic machine learning, but I haven't directly used it, so I can't speak to that. So back to the chapter. We've got these instructions to install PyTorch. I don't know how many of you have already gone through this process, but just to show how easy this is, if you have Python already installed, if you have Anaconda, it's roughly the same instructions. There's two different things that you need to pay attention to. So here's the link if you're trying to install. Here's what it will take you to, and it will try to automatically fill in this information for you. So right now I'm on a Mac. I don't have CUDA, and it's telling me right now Mac doesn't have CUDA, so don't worry about that. You tell it what OS you're on. You tell it whether you're using Anaconda or pip or some other option. You tell it if you're doing it Python or C++ or Java. And then you tell it which CUDA version. For me, it doesn't matter because I'm on Mac, so it's not even going to try installing CUDA. But this is a very important step. So if you want to get these running with the GPU, I highly recommend going down the Conda path. That's much easier than doing the pip path. With pip, you're going to have to install CUDA on your own and figure all of that stuff out, and that's a massive headache every time I've done it. But if you do it with Conda, then it will automatically install CUDA, CUDA-NN, put it all in the right place, make sure the system knows where it is, make sure PyTorch has access to it, and that'll be much easier for you. So I highly recommend going through that process. And so for me, I ran this right before the meetup. I plugged all this stuff in. I haven't installed PyTorch on this laptop before. So I just basically took this command, and you can theoretically put it in a Jupyter notebook if you're familiar with those. You put a exclamation mark, and then you just can hit run, and it will try to run all of that stuff. That's one option. And then the other option, I don't have any terminals open. Hang on. The other option is you just plug it into your terminal, you just paste it in and hit enter. And as long as you're in Conda or your Python environment or whatever else, you can just run that and it will do things correctly. So I already have it installed, so it didn't actually run anything, but for you, it'll probably pull up a bunch of stuff and then ask you if you want to install the packages that are included in that. They recommend.
Just a brief note, Ryan.
Yeah.
So some people, if they have Anaconda or Miniconda, they might just run everything in one environment. But if you're creating multiple environments, so then what I did is I just created a brand new blank environment. And so I have a separate environment where I'm going to run my PyTorch stuff from the environment where I have, say, for example, all my TensorFlow stuff. And then just in case one of them needs a different version of CUDA from the other, then they're not going to complain with each other.
Yeah, yeah. So still on the requirements, they recommend Jupyter notebooks. I also recommend those. They're good to just play around with the code and directly see what's going on. You can kind of go line by line and see what's happening. And they say that at some point we'll need 200 gigs of storage if you want to actually run through one of the specific tasks. I'm sure we can get most of the way through the book without needing that much storage space. And if it really comes to it, you can just skip that part and act like you did it. So that's it for chapter 1. One of the things that I did is I followed along with the code. So they had some notebooks just to apply it a little bit and be able to see what's going on. So one of their exercises was saying just make sure that you have the right version of Python installed, 3.6 or up. So I ran that. I have 3.7.3, so I'm good in that regard. and then importing Torch, looking at which version of Torch I have. I have 1.6, and then looking to see if I have a GPU on this system. Do I have CUDA available? I don't, because I'm on a Mac right now that doesn't have a NVIDIA GPU. And then they do some basic math operations with it. So they load a tensor of just one, so it's 3 by 3 of ones, and then this is another 3 by 3 of ones, and then they just add them together and you get a 3 by 3 of twos because you're just adding one everywhere. And then they show, here's what you would do if you had a GPU. You would push it, the tensor, to CUDA, and then you add them together. But it doesn't work for me because I don't have a GPU. It tries to push it to a GPU that doesn't exist. So that's not a big surprise there. And so that was all the code that they had for chapter 1. So going back to the notes along with chapter 2, what they were trying to show is various different applications of PyTorch. So they show you don't really need deep understanding of how to train a model and all this other stuff. People have made models and you can just apply them to different data and see what happens and still get some use out of it. And so what they're showing with this one is classifying various different pictures. And so there's this famous Imagenet data set that has millions of images, and it's got 1,000 different classes saying basically golden retriever, ladybug, bell pepper, table, a bunch of different stuff. There's 1,000 different classes. And people have been competing for years trying to get the most accurate system at classifying all of these images into their different groups. And so with this, we can take that and we can apply it to our own images, and we can see what do these models think this random image is that we plug into it. One of the things that they talk about is understanding what is the actual input to these networks. So the input is the pixels of the image. So it's red, green, blue, and then it's the width of the image and the height of the image, or vice versa. And so they show that we need to pack that into a tensor. It might originally come in as a NumPy array or a pill image. And so we turn that into a tensor, and then using the Torch Vision pre-trained stuff, we can pull in AlexNet and ResNet, and then we can apply that to the images and we can see what it comes up with. So in their example, they're showing, here's this nice Torch Vision package. It's got a bunch of models inside of it. We can look at what models it is by doing the dir of it. So you can see here's a whole bunch of options and various different functions in there. They load this in, and what this is doing is it's taking ResNet and it's actually grabbing the pre-trained version. So it's downloading all 170 million parameters from the internet, and then it's making a nice model for us. And if we want to inspect what are all of these layers, what is it actually brought in, we can just print the variable, and then you can see here's this whole stack of layers that it brought in. And then they're showing the process. We need to make sure that our images are the correct shape and size. And so they're resizing the base image that they have, and then they're center cropping it, and then they're turning it into a tensor. So it's originally coming in as a pill image, and they're turning it into a tensor, and then they're normalizing it. We can talk about why that's significant some other time. But basically, they load in this cute puppy picture, and then they pre-process it with the function that they defined, and then they have to unsqueeze it because the neural network assumes that you'll have more than one image typically when you're training and stuff like that. So you basically just add another dimension to this tensor, and then they put it in evaluation mode with this call right here. And so they mentioned there's some reasons that why you need to do that. We don't need to really get into the details of that yet. We're just trying to show the application. They plug the image into the ResNet, and then they get this massive array out of it. that's just a whole bunch of numbers and probably doesn't make any sense. And so what they have to do is load in the actual class indexes telling us, okay, this probability it's telling at position 0, that's referring to golden retriever, and this one's referring to some kind of cat or bell pepper or whatever else. And then what they're doing is they're taking the max. So they're saying, what does the network think has the maximum likelihood of being that class? So it turns out that it has high confidence that it's a golden retriever, and there's a few other dog types that have some percentage there as well. And so they've set it up so it's just printing off the top 5. And we can see that it does a pretty good job with that.
Yep.
Sorry, quick question,
yeah,
if you don't mind taking it. I got confused because they first talked about AlexNet, and then they went into all of the ResNet stuff. And I went back just for the fun of it, and I ran the same, the same setup through AlexNet, just based on what was in the AlexNet initialization at the very beginning, right? You see, it says it creates it, in paragraph 3 there, but it doesn't actually use it at all, right? Because it's trying to use it. And I got very bad results using AlexNet, and I'm trying to figure out if, number one, I think it's cool from the standpoint of all you have to do is swap out the name on the model, and you effectively have swapped it out. I mean, the function interfaces are the same, which makes it kind of nice.
Yeah.
But on the other side, I tried it with pre-trained equals true, and it doesn't accept that one. So at least it didn't for me. But yeah, that was kind of the thing, was like, do you think I'm missing, like, the AlexNet is worse? I didn't have the pre-train in there. Like, any thoughts on?
So one of the things they mentioned in the chapter was that the uppercase versions mean something different than the lowercase versions. And so if we look here, this is the uppercase version of AlexNet. This is the lowercase version of ResNet. So
yeah, you want the lowercase.
Yeah, so I'm assuming the lowercase version is going to work. Yeah, so that's downloading.
Okay.
I'd have to look back in the book exactly what the difference is. My belief was that the uppercase version is just the architecture, though, and then the lowercase version allows you to also have the weights. I don't know exactly why they have that distinction, but that was my understanding of the book.
Okay.
Also, just to add whatever Ryan has said, if we are just like putting in the images, not training, so we need to put the model to evaluation mode as well, like Ryan did. So if you didn't do it in your case, then that might also mess up with the outputs.
Yeah, I think the main thing, though, is that the uppercase letter, the generic classes, you could make whatever size you want. So like a ResNet 30 may not exist, but you could make for yourself a ResNet 30. The lowercase ones, you can only use the ones that were actually published, and without the pre-trained weights, then it's just going to be the early random initialization. So you're just going to get garbage out.
And in this case, it definitely looked, because I was using the uppercase, so it definitely was not pre-trained. And that's, I was just, I didn't catch that distinction between the, I thought the pre-trained part, I just didn't catch the distinction between the module identifiers.
Yeah, I think it's just the capitalization gives you a different version.
Yeah, so like for example, if you have a ResNet 50 and you're like, well, it's deeper than the original AlexNet. How would AlexNet have done if I just made it deeper? You can use the capital AlexNet to create, you know, a 50-layer deep AlexNet if you were curious about doing the experiment. Unfortunately, if you want to do an experiment, you got to train it from scratch. You don't have pre-trained weights that you can use.
I wanted to mention something about Imagenet because, you know, in any lectures that you see on Introduction to Deep Learning, they're going to talk about the success. AlexNet was the first deep learning model that actually vastly outperformed anything that that came, you know, that was a competitor to it. And that made people realize that deep learning had an awful lot to offer. And I was just at random, I picked up a copy of the communications of the ACM that I used to get. I'm not a member of the Association of Computing Machinery. I don't belong anymore, so this is a couple years old, and I opened it at random. It was an article about a person called Fei Li, and when she was a grad student, she was the one that launched the Imagenet project. So everyone talks about Imagenet like it just appeared, and there's actually a person behind it. She's now a distinguished professor. You know, Wikipedia says she's 44 years old, but I just thought it was kind of interesting, you know, that it was a Chinese grad student that actually did this, and then she organized the competition that sort of put deep learning on the map. So I like to pay attention and give credit to the people who are responsible. So Imagenet just appear by magic somewhere.
And I want to piggyback with one question though, like from as a beginner, I wonder how, I mean, are any people updating like the Imagenet and also the weights for the ResNet? Like if like there are some brand new objects, right? Like I'm sure that there are objects or images that have not been existent before. How do we account for that?
So the Imagenet is, in some senses, a toy problem. It only has 1,000 classes, and it's just stuff that people have decided to throw in there. So it's just various different breeds of dogs, a car, a train, just kind of various generic things. It's not trying to capture all of the knowledge of the universe. If you want something beyond that, you need to train your own model. So it has not been updated. It's the same Imagenet from 2012 or whatever year it was released. And people have just been continuing to iterate on that data set as a benchmark to try to say, how do we continue to improve on this data set and reduce our error amount?
Yeah, and for what it's worth, the labels come from WordNet, which is even older than ImageNet. It's like ancient.
Oh, yeah, I was going to say that these, because there was like LayNet, right, which is one of the first ones, which then AlexNet, I think, is built off of, which then ImageNet is built off of. So, and these go back not, you know, before 2000s. So yeah, this is all, yeah, there is an origin somewhere.
Mm-hmm. Yeah.
But is there not like a benefit to the entire industry for some party to maintain some of this kind of widely used data sources or weights as time goes by?
I think I could see how there's value there, but I think that I'm not aware of anyone doing that effort and making it public. So I know that Amazon and Microsoft and whoever else has their various services where you can just plug in anything and it'll say, this is a person writing a button, this is a person writing a hoverboard, or something new that just came out somewhat recently. And I'm sure they're keeping theirs up to date and matching it with their image searches and stuff like that. But I don't think that anyone has necessarily made all of that public. I think that most people are still kind of just messing with ImageNet, at least in research. I don't know if there's anything commercially available outside of the big few, and they're not open sourcing them.
Yeah.
So on to 2.2, I guess. So they talked about GANs a little bit, generative adversarial networks. They kind of just skimmed over it. I wouldn't really spend too much time thinking about it. They'll discuss it more in later chapters. They just wanted to show the application here. They're basically showing they've got one neural network that's trying to build realistic images, another one that's trying to tell whether an image is fake or not. And so the two networks are battling it out. Eventually, the generator gets very good at making realistic images and can fool the discriminator. And then you're able to generate some interesting images. So that's what they show in this CycleGAN notebook that I ran a while ago. And basically what they're showing is you've got this model that's been pre-trained, and they've got this picture of a person on a horse, and then they can apply the network to it, and they can turn the horse into a zebra with that model that they've trained with the GAN, or is a GAN, I should say. And then one of the exercises at the back of the chapter was apply this GAN to the golden retriever from the previous lecture. And so what I did is I just plugged in the different path to the golden retriever, and then we can plug it in and we can see what a zebrified golden retriever looks like. And it adds some zebra patterns in random places, but obviously it doesn't fully zebra it, unsurprisingly, because that's not the kind of data that we've seen before. Kind of an interesting just thought experiment though. So the next one they talked about was this Neural Talk 2 from Andrej Karpathy. He's very famous. You should probably know who he is. He's director of AI at Tesla now, but he's also written a whole massive amount of tutorials and various other things. I was working on reinforcement learning stuff this past week, and I ran across multiple different websites that he's spun up showing various different visualizations of the reinforcement learning concepts. So definitely worth looking into him because he's got various different cool tutorials that you can probably learn from. And basically this Neural Talk 2 model, what it does is it's able to take in an image and describe what's in that image. So it uses a convolutional neural network. It reduces it down to some vector, and then it outputs a series of text to say, this is a horse with a person on it. And so that's what we can derive from that. They showed some lines of code in order to run it, but they don't have a, what's it called? They don't have a notebook that goes along with it. So I don't have anything to show for that. And then the next thing they showed was Torchhub. So in the first thing we were looking at Torch Vision that had all of the computer vision models that had AlexNet, ResNet, all of that other stuff. And Torchhub is supposed to be more of a just general, like, here's where all of the models get collected and we can share stuff and it's in the standard format. I haven't personally used Torchhub before. I don't entirely see the value of it. You go to the website and then it only links to 31 different models, and it just links it directly to the GitHubs. And so most of the time I've found that I'm interested in some specific model, like they have some translation models there. When I'm looking for translation models, I Google translation models. I don't go to Torchhub and then look on Torchhub for translation models. And I just find the GitHub directly. So that's been my experience, at least. I'm sure there's some value to Torchhub, but I haven't personally seen a whole lot. So that's it as far as the contents of the chapter. They also had another notebook that trains for MNIST. I'm not sure if you guys are familiar with MNIST, but it's a similar style of data set to Imagenet in that everyone uses it for a simple kind of starter problem. And what MNIST is it's some handwritten digits, so just numbers, basically. You've got a 28 by 28 block of grayscale images, and people have written down, here's a 9, here's a 7, here's a 3, and we have the labels for that. And so you train a network that tries to figure out what does a 9 look like, what does a 3 look like, and so on. And so this is a very simple example showing here's how you might build a neural network and train it with these simple parameters. And you can see it's only probably 40 lines of code, and it ends up getting a decent result in terms of being able to classify the digits. And this was run just on my CPU, so you don't even necessarily need a GPU for this because the data is relatively small. So any questions for anything related to the chapter? Because I think we're through the majority of the content now.
I had a question. So I was just trying to launch something from Torchhub, just a simple model at ResNet, and just try to classify a picture, and I was just following their example code. But I only got the tensor back. Where do we find from Torchhub how to actually apply the class from the pre-trained models?
Off of Torchhub?
Yeah.
So the way they did it in the book is they had this
labels.
So they had this file that was just basically the Imagenet classes, and they loaded it in, and then they could basically just do the mapping and say this is this class and this is that class just from the matching indexes. So that's one way to do it. I'm not sure if there's a better way to do that directly with Torchhub. I would think that that might come with something extra along with it, but I'm not that familiar with Torchhub, so I can't
maybe
for certain.
Just look in their GitHub repos and hope I find it that way, or?
Yeah, potentially.
Okay.
I just want to note something about Anaconda. The thing is that sometimes when you install a package, you can get a conflict of version if there are other packages which are required, but they're much older. So I would recommend to run conda update all, which you probably know. Which is not so well known is that when conda updates and installs, it does not remove all packages. So you need to do it yourself. I once ran into almost 20 gigabytes of my conda folder until I learned it. So you clean it and it will remove all packages, and the packages tarballs are removed separately. You need to put in white twice. Okay.
Thanks. I'm not really an expert on Anaconda, so that's good to know. I haven't worked with it a whole ton.
Hi, Ryan.
Hi.
So this is some part of the book where I see that they said, since current Apple laptops do not include GPUs that support CUDA, the precompiled macOS package for PyTorch are CPU only. So does that mean when we are running on Mac, we cannot parallelize or use PyTorch ability to do parallel computation?
So you can use multiple CPU cores, but you can't use CUDA because, at least in my understanding, there's no way to install CUDA on a Mac. I'm sure there's probably someone who has figured out how to do that, but it's probably going to be a massive headache.
If I recall correctly, CUDA is a NVIDIA only item, and the Macs, even the higher end ones, only come with the Radeons.
Mm-hmm. Yeah, I know that the one that I have right now has a AMD
the Radeons
5X. Yeah, so it can't do CUDA. My understanding though is that AMD has been working on this ROCm package that is supposed to be in some way a rival to CUDA, and eventually there's supposed to be some way to do basically plug in ROCm instead of CUDA. But at this point, I haven't really seen anyone utilizing that. It's still in fairly early stages, and I know that people have tried to install it and had a bunch of hassle because it's just not complete yet.
Yeah, and just to clarify one point, Ryan, in the chapter 1 test your system notebook, you showed where it said copy this tensor to GPU memory and you got an error message. My understanding is that all the production code has, ifs around it to see if you have a GPU. So you should not get an error. You can run any of the code in this book, even if you don't have an NVIDIA GPU with CUDA. It'll just take longer on CPUs than it would on the GPU, but you shouldn't have to worry about getting an error message. So Ryan, people could either type or ask questions if they have other things they want to talk about, but I'll just throw out. So there was a suggestion I thought was kind of fun. If you guys are interested, what we can do is we can create some breakout rooms, so we can like divide people up into 5 different groups. If you just want a chance to say hi to a few other people, get to know somebody, depending on, you know, we could just do this for 5 minutes. We could do, if you want, we could do speed dating. We could just mix it up, do 2 minutes, and then change up, do a new set of 5, you know, random breakout rooms. Since it is virtual, we don't really have as easy an ability for, you know, multiple people to talk and say hi to each other.
Yeah, that sounds good to me.
All right. Any questions, any other comments anybody wants to ask before I think what I'll do is I'll try to just blast everyone, force everyone into their breakouts, just for speed.
Sounds good.